Hello guys, welcome back to the part 2 of the projectile motion. In the part 1 we have discussed a lot of basics about the projectile motion, uh, the motion in two dimension, and this is the part 2. I'm just changing the name here from part 1 to part 2. Yes, so welcome back to the part 2. In today's video we're discussing in detail about the projectile motion. First of all, if you see the beautiful diagrams over here, before going on to that, let me show yesterday's concept we just discussed. This is the motion, something called as a projectile motion, and this is a kind of example of two-dimensional motion, uh, like the circulatory motion. And this is a ball, and this ball is don't consider this ball moving in this direction. This would not be the projectile motion. For suppose this ball is thrown from this direction and it is going into this, and it is going back into this is now the projectile motion, right? This is into the two dimension. You maybe this is the peak point, and you will see, and here you can see a diagram. Hopefully, after understanding all the concepts of projectile motion, we'll be looking into this diagram. This is a wonderful diagram. Hopefully we'll be doing an exercise of it in the part 3. Hopefully we'll doing this one thing with different experiment, different conditions. Right now I'm not discussing this one. Now let's move forward for the projectile motion. Here is a very beautiful definition of our today's topic, that is projectile motion. Such a motion in which a body is thrown at an angle of certain, at an angle, sorry, there's a mistake, at an angle, certain angle, at an certain angle. Okay. Wait a minute. At an certain angle. Right now, this is good to go. Let's back. Uh, um, Such a motion in its body is thrown at a certain angle in a way that it makes constant horizontal velocity, at the same time it's make move slowly into the gravity. I know that this has just lifted up through your minds without a concept. So before understanding the definition, let's look into the concept, and automatically you will get to know about uh, the definition, hopefully. Now let's discuss this projectile motion with help of diagram. And here I have got the x-axis, and here I have got the y-axis. And for suppose, what I do now is this, that I've got uh, this one initial point, and the point on which the projection start, that is known as the point of projection. And for suppose this is thrown in this direction, and now this makes an angle theta, right? And I'm just telling you very important points. You just need to write it. I'm not writing every single thing. Definition: the point of projection is over here from the projectile motion started, while the angle made by it is known as the angle of projection, while this will move into a direction like this, in this way, right? Move in this way. Okay, so this uh, this is a part 2, right? So in this video I'm just explaining basic things, uh, that is like the path covered by the x-axis, that is known as range, like from here to here, it is known as the range. Just need to write it up, right? And the path over here, the curve, this is known as a projectile motion which is covered. The projectile motion covered is known as the trajectory. To mention it is very important again. This is known as the trajectory, and trajectory can be of two types, like this one which is making an angle. This is known as a uh, you know, oblique projectile. The theta is known as oblique projectile trajectory. And in the same case, you are standing at a pillar and just uh, you know, throw a ball, and over here you're standing and then your ball is thrown and it will cover distance like this. Now this is these both are kind of linked, but not totally same. So this is the oblique projectory oblique project oblique projectile, and this is the horizontal projectile. This is half. If there is involvement of angle, that this is the oblique, while there is no involvement of angle, that is uh, what we say, that is the horizontal projectile. This is the concept of oblique projectile and horizontal projectile, while the shape formed by the trajectory is in projectile motion. The shape formed by trajectory is always parabolic. To mention this, the shape formed by trajectory in a projectile motion is always parabolic in shape. Okay, so let's move forward. uh, okay, so hopefully in the next part, I will get more into deep on the basis of axis. I will be discussing the concepts. I'm not trying to get into it because that would be a long video. Then I'm hopefully not discussing the definition in this video. Let me introduce some other examples for you, for linking it with the real world. We have got uh, good lot of examples, like a football kicked by a player. uh, a football kicked by a player Football kicked by a player is an example of projectile motion. A football kicked. Okay, that's take long time. I'm just not writing. A football kicked. Okay, so that is an example of projectile motion. A missile shot from a gun, object thrown from a certain height. Many people do think that this cannot be projectile motion because this is half, but this is projectile motion as well, because the same trajectory, parabolic trajectory, is being formed over here as well. Even though we have got oblique trajectory and horizontal trajectory difference, but the projectile motion exists. While we have got some exceptions, like the, the the motion of a plane or a plane is not a projectile motion. Remember this. And uh, let me introduce some other points, like this is the angle of projection and this is the point of projection. And have we got any other? Let me see. Yes. Here we have got the initial velocity from which the object is thrown, and here we have got the final velocity, uh, which is final velocity. And I want to include a point over here that uh, this is denoted by v naught. The initial velocity is denoted by v naught, while the final velocity is denoted by capital V. And uh, let me see any other points, like um, okay, so we got another point over here, that there is a certain height on which there is a peak reached by the projectile motion. uh, that is the maximum height, and on that part, the motion, that is a sort of place where the motion of the particle or the object thrown or the ball at an instant that is stopped. There is no motion. The motion gets zero. Hopefully in the next video we'll be discussing this, and you will get to know this again, uh, with more clearance. So meet you guys in the next video. Till that, goodbye.